Hello everyone, welcome to new class. Today's class is about series RLC circuit and admittance of AC circuit. Let us study about series RLC circuit. Figure shows an AC circuit in which resistance, inductance and capacitance are connected in series. An AC supply at a frequency of f Hz is applied to the circuit. Let V be the RMS value of voltage applied to the circuit. VR equal to I into R be the RMS value of the voltage across resistance. VL equal to I into XL be the RMS value of the voltage across inductance. And Vc equal to I into Xc be the RMS value of the voltage across the capacitance. Let I be the RMS value of current flowing through the circuit. This is the phasor diagram of the circuit. Taking the RMS value of current as the reference vector, that is, it is represented by the vector OA. The voltage VL leads the current by 90 degree, that is BC. The voltage VC represented by BD lag the current by 90 degree. And the phases BC and BD are in direct opposition, and hence their resultant is given by BE. That is BE is equal to BC minus BD. Assuming BC greater than BD. So the applied voltage will be the phasor sum of OB and BE. That is OE will be the applied voltage. So this is the phasor diagram of the series RLC circuit. If we assume VL is greater than VC, and this is the phasor diagram of the series RLC circuit. If we assume VL is less than VC, then the resultant applied voltage will be this one. So BE is the net reactive drop, that is VL minus VC is known as the net reactive drop. That is net reactive drop BE equal to BC minus BD, that is OE square equal to OB square plus BE square, or we can write V square equal to VR square plus VL minus VC the whole square, that is I into R the whole square plus IXL minus IXC the whole square. VR is IR, VL is IXL and VC is IXC. Taking I square outside, we get I square into R square plus XL minus XC the whole square. Or we can write V equal to I into square root of R square plus XL minus XC the whole square. That is, from this we can write I is equal to V by square root of R square plus XL minus XC the whole square. That is V by Z, where Z is the impedance of the series RLC circuit and is given by square root of R square plus XL minus XC the whole square. Let X equal to the net reactance, that is XL minus XC, then we can write the impedance Z equal to square root of R square plus X square. As the voltage drop across the inductance has been assumed greater than the voltage across the capacitance, the resultant circuit becomes inductive. Hence, the current in the circuit lags the applied voltage V by an angle phi. Then, the power factor of such a circuit is lagging. And in case the voltage across the capacitance is greater than the inductance, that is, if Vc is greater than Vl, then the resultant circuit becomes capacitive. The Phasor diagram is shown like this. Thus, the power factor of such circuit is leading. Hence, if the resultant reactance is positive, the current lags behind the applied voltage, or we can say lagging power factor. And if it is negative, that is the resultant reactance is negative, then the current leads the applied voltage, or we can say leading power factor. Power factor is given by cos phi is equal to R by Z, and this is the impedance triangle of series RLC circuit. That is, this is resistance and this is the net reactance, that is XL minus XC, and the hypotenuse is Z, that is impedance. So, if XL minus XC is positive, we get a lagging power factor, and if XL minus XC is negative, we get leading power factor. And the power consumed is given by P is equal to V into I cos phi. Now let us study about admittance of an AC circuit. It is represented by the letter Y. Admittance of an AC circuit is defined as the reciprocal of impedance. Its unit is Siemens or mho. Symbol is S or ohm inverse or mho. Let Z be the impedance of circuit equal to R plus Jx, that is resistance and reactance. Then admittance is reciprocal of impedance, that is 1 by Z, that is 1 by R plus Jx. Now multiply the numerator and denominator by the conjugate of the denominator. Conjugate means changing the sign of imaginary part. This is real part and this is imaginary part. So changing the sign of the imaginary part, we get a conjugate, that is R minus Jx. So multiply numerator and denominator. Then we get R minus Jx divided by, this is in the form of A plus B into A minus B, that is A square plus B square. So we get R square plus X square, that is Y is equal to, separating these two parts, R by R square plus X square minus J into X by R square plus X square. So in the case of impedance, Z is equal to R plus Jx. So in this case, the real part is resistance and imaginary part is reactance. Similarly, the real part of admittance is R by R square plus X square, is called conductance, represented by the letter G, and its unit is mho. And also it has a second part called the imaginary part, X by R square plus X square, is called the susceptance represented by the letter B. Also its unit is ohm. And in general we can write admittance Y equal to G plus or minus JB, where G is the conductance and B is the susceptance. So we can write in general conductance G equal to 1 by resistance. The susceptance has two parts, that is inductive susceptance BL equal to 1 by XL equal to 1 by omega L, that is equal to 1 by 2 pi FL, and capacitive susceptance BC equal to 1 by XC equal to omega into C equal to 2 pi FC. Thank you for watching the class. If you like the classes, please like, share and subscribe my channel.